All right, today gonna do one on the MLA-2500B. First a walkthrough, and then we're gonna put it on the bench right quick on this one. We're done with it. This one's been monobanded to B, and over here is the MLA-2500 Non-B, and this one has all the ham bands in it. The original, of course, was the MLA-2500. It had 28 megahertz or the 10 meter band in it. Well, actually better on the band switch down there. It had 28 megahertz, the 10 meter band in it, and that's where you tuned it at approximately. And then on the B model, due to the FCC's tighten down, they completely got rid of the 10 meter 28 megahertz band, because any amplifier that will work on 10 meters or work on 11 meters is just that close, unless they put in a specific circuit or filter to filter out 11 meters, aka the Heathkit SB221. That's one of the things, the difference between the SB220 and the SB221 is they put in a and they call it a filter in the schematics. They don't say what it did, but on the input side they called it a filter. And that filter, I guess it was a filter because it specifically filtered out, and it was tuned for 11 meters only. It grounded out or filtered out 11 meters. 10 meters was okay. They didn't have 12 meters back then, and 15 meters was okay, and they call that the stupid thing a filter. And yeah, it was a filter. But anyway, getting off track, the original MLA-2500 had a power transformer, or the high voltage side of the transformer had a single tap, and it did have the CW/SSB switch, and all that did was change the fan speed. If you were on CW or a constant, the fan speed was on high all the time, and if you went to SSB, it lowered the fan speed. But it also has a heat sensor in there. That's that green thing right there, and you see it's kind of close to the tubes. That's on purpose, because when that gets to a certain temperature, that kicks in, and when that kicks in, it sends full power to the fan to turn up the fan when the tubes get, let's say, warm or getting too hot on SSB. But on CW, the fan was on full power. On the MLA-2500, on the B, on CW, or the low side, it's got a dual tap on the high voltage transformer, and on CW it's on low for the high voltage, and it runs about 1800 volts, and on high it runs about 2300 volts on high. And the fan is strictly on low unless that heat sink sensor still there kicks in, and then it turns the fan up. The reason they did that fan on high makes a lot of background noises, and hams didn't like to have their station that sounded like a jet going on. So it's got the sensors, so unless you start pushing this thing, the fan is gonna stay on low. But you push it hard, tubes get hot, it's gonna go on high. I had asked about that resistor there, or mentioned it in one of the other previous videos on this. That does go to the input. Somebody did say that, and that's exactly what it does. That resistor, I believe, is 100 ohms, and it's tied to the input side going into the tubes. And since this amplifier doesn't have a tuned input, and it's cathode driven, but on its own, the cathodes on these tubes are about 500 ohms each, I think. So it'd be 250 ohms. So you'd have a really bad input SWR if you didn't have something on the input. So instead of making a tuned input, again, Dentron, they made an amp to do the watts, but it's not the most well engineered or well designed thing in the world, and people keep asking, why did they do that? Why did they do this, Tram Doctor? Well, they want to make money. They, you know, that's why they build amps. So they want something to do to watch for cheap. So what they just put a resistor on the input. It's non-inductive, so it won't mess with the RF, and it's 100 ohms to ground, so it gives the input kind of a fairly decent match. It's not the way to do it, or the correct way is to get a tuned network that give you the right capacitance and inductance to help filter out that input. But the cheap way is to just throw a resistor on there, like going to ground, and even you can see that small coax cable coming out. That's the coax cable goes from the relay to the input of the tubes, and that resistor is also tied to the same point of the input of the tube, so it gives it a good input match. And this is what it looked like mono-banded. All the ham bone stuff is taken out. Just basically your tubes, your plate choke, your blocking caps, your tank coil, and that's all you need. About 4 turns. Again, I think this is 3.5. That's usually the magic number, somewhere around there. And then it goes out to the relay. So on this one, it goes, the main power goes from the tubes, plate choke, blocking caps, through the coil, and then out to the relay. However, these two lines over here, that goes to your tune cap, and then that one goes to your load cap. And I left this resistor in, this capacitor in there, that's also tied to the load cap. It can get away without it, but it's not hurting enough. It's not switched in, it's soldered in permanently, so we left that one in. And other than that, just your basic power supply stuff. Your cap, this does use a voltage doubler for the transformer. I didn't look up how many amps the transformer do, but it's a pretty good sized transformer, a lot more rugged than the Heathkit SB220, right? Heathkit SB220 is economical, thrifty, cheap, low cost amplifier. But the Dentrons, they put in the power supply. Pretty rugged, 24-pound transformer, even though they used the voltage doubler circuit. And that's the diode bank. I don't know if you can see it in there. That's a relay connected to the delay. That's tube there. It's a delay tube. It's a delay timer, 90 seconds. So I got it unplugged and off like a double safety when I'm sticking my fingers and stuff, and it's drained on the voltmeter there. By the way, that's a safety thing. I do try to make it off at least 2 places, because if I'm playing around and I got it plugged in and I actually hit that on switch while this thing's plugged in, it's gonna be trouble, and I ain't ready to go yet. So anyway, the time delay, it does apply voltage to the tubes and the bias and everything else, but it doesn't let you key this amplifier for 90 seconds until the time delay kick in. And also, it's like a poor man's soft start, because even if you have it on high on SSB with the low, high, or CW tune switch, it will start off on low, on the 1800 volts, until that time delay tube kicks in the relay, and over here it kicks in this relay for the high or low voltage tap, for the power transformer. So even if you have it on high, until that time delay kicks in, it's going to start at the 1800 volt tap, and then when that time delay kicks in, it'll jump up to the 2300. That's a poor man's soft start, because other than that time delay, it doesn't have a soft start in this amplifier. Over here are a lot of the ham band components that were taken out. The tank coil, the tank coil, the band switch, and all those capacitors they switched in. Somebody mentioned Alpha. Alpha built amps that were about 3 times the cost But you know, like one of the things Alpha did, they had, you know, bigger, longer. This is the load cap, load and tune caps. And on the Alpha, since you need a lot more capacitance for the load, they would double up. They had two of those big long load caps where, you know, this Dentron has one smaller one, and they switched in all the capacitors. That's just one thing of many different things of the build quality between this and a more high-end expensive amp. But again, with most stuff, especially, you know, Dentron, which is, you know, kind of like a low-end ham, and it was used by a lot of CBers because it do the watts, and, you know, they were a good price, but it was on the lower end. And by the way, all you Heathkit lovers, so is Heathkit. Anyway, we're plugging her in, and we're going to turn her on, and we're on high. But again, even with her on, it's going to start out at that low voltage tap. It's running 1600 volts right now, and it's a 90-second delay, give or take. So I guess I'll run my mouth for 90 seconds. Here are the original high voltage filter capacitors out this thing. There were 6 of them. They're replaced with modern ones with actually more capacitance, so it should make the power supply a little bit stiffer on them. Why they went with, you know, a low capacitance, if you look at it, 500 volt, 100, 150 UF, which is really low for 6 in series for, you know, this amplifier. But again, cost. But these caps originally come with this black paper or cardboard top on the Y. So rhetorical question. I already know the answer, but a rhetorical question. You get a attaboy for the first person who answers this correctly. Why do they put these paper covers, or whatever you want to call them, these cardboard paper things, over all the capacitors in some amplifiers? I mean, this is, you know, the same thing. If you take the paper off, this is what it is. So why do they put that cardboard paper on the high voltage bank of capacitors in some of these? Anybody got a guess on that? You get an attaboy. I used to play racquetball, and I played in a little small tournament, and, you know, I won it, and they's like, okay, you get an attaboy. That's what you won. So whoever guessed that right gets an attaboy. Anyway, I heard my relays clicking and all that, and you see it jumped up to the 2300, give or take, on its own. Even though I still had it on high, it started at 18 until that time delay came up, and the, you know, ready light came up. It's at 18. Then when that kicked in, it kicked it up to the 2300. I'm going to turn it back to low, and you can see it, you know, going back down. But again, that's that poor man's self start or soft start. It'll start on the low voltage tap to 1800, and then when the time delay kicks in after 90 seconds, it'll jump up to the high voltage. When you key it down, you know, they're ready. Go to transmit there. I'm just hitting the foot switch on it. You got the standby CW tune, you know, it's high low. You got 1 meter over here, and this is kind of CB stuff. You got a watt meter. That's kind of CB-ish. You know, most people use either a dedicated plate current meter instead of a watt meter. If you're going to use two, they use either a plate current or a grid current meter. They don't use one just for a watt meter. The watt meter would be switchable if it has it. That's, you know, CBers like to see watts on the watt meter, where hams, they use that plate current meter and a grid current to tune it. Even though this does have a switchable multimeter over here. You can read plate volts, which it is now, plate current, and then grid current. And another funny thing about Dentron, the way they got the grid current measured, it's really off scale. Those tubes can only take like 50 milliamps of grid current. And the way they got it metered, 50 milliamps would be way over, you know, down here. So if you're going past like halfway before that 1, you start going past that, you know, 0.5 where that would be, you're overkilling the grid current. But again, Dentron made these amps to do the watts, you know, not to last long. So people, you know, could be driving the grid current way over here or half scale on the meter, and they'd be killing the tubes, just killing them. You know, actually the tubes in these are very soft because of that. You know, I got them for a good price, so I'm happy that the tubes work at all. And as somebody mentioned when I was talking about that resistor there on the input side, that people do that because the tubes get soft, so it takes more drive to get them to kick back up again. And that resistor is you know, tied to ground, so it's you know, backing some of the drive down. So what people do who want more watts again is they cut that resistor going into the input side, so it's more drive making it to the tubes. But the downside of that is, one, is easier to overdrive these fragile tubes, you know, because you don't have that swamping resistor there. It's not cleaner that way, and you're going to have a very high input SWR on your amplifier or transceiver, whatever you're driving this thing with. It's going to make it hectic on it. And tubes are a little bit forgiving, but if you're driving it with a transistor amplifier or a transistor transceiver, it's not going to like that high input SWR without that resistor. So anyway, hopefully this thing is still tuned up and all that, and it's not doing a lot with the soft tubes. I recently done one on the MLA-2500, and I switched the tubes around to put it in this, and this one does a little bit more, like I say, about 5% more. 5% more without all the ham band stuff in it. It's more direct, closer, not going through the band switch and all those extra coils switched in, and the long path and all that stuff. So it does a little bit more. I'm using the same driver and same setup. I just made a video on this one with the ham band in it, and I'm gonna make the video on this one, even though I've been talking a long time, didn't mean to. So anyway, we're on the 2000 watt scale. Audio, that's just the driver. Audio, just putting in about 50 watts on the 2000 watt scale. And I'm gonna key her down, and with soft tubes, what do you think we're gonna get? Not a lot, not as, you know, not what it's really capable of, this amplifier. So anyway, dead can 200. Audio, talking about 6, maybe 650. Whistling to about 8 on average. And I gotta put the mic down, carefully reach over here, and gonna put it on peak watts. Audio. If I had another hand, can tweak it a little bit, I can get just past 1,000 on this thing. Peak. Audio, even on the, that's the watt meter. Audio on the amp, not reading a lot, but mostly got swing in there, and these old stingy watt meters don't like to read a lot of swing. And remember I was saying the grid current is barely kicking up because I'm not driving it very hard, so the current is almost, you know, nothing. But these tubes don't take much current. I don't like the way they got that metered. Another, you know, bad Dentron. Plate current. Audio. 0.2, 0.3 amps. So you know, with 2300 volts on the plate, what's a quarter of that? About 600-700 watts. You know, but again, swing watts is a different thing than dead key watts. And again, the plate voltage. Audio drops a little bit. And by the way, I'm on 110. Even though I got these new caps in there, my line voltage is dropping a little bit on the 110 line. Audio. Actually, I think it's this one. I think even a direct 110 line. Audio. You can see it drop a little bit. If I put that on 220, it'd probably eliminate most of that drop, and I'd get probably a couple more 100 watts out of this thing. But anyway, I got it on 110, and I think that's about all I wanted to do today. So anyway, this is the MLA-2500B amplifier, soft tubes. With good tubes, it'll probably do twice that easily. And if you pushed it, but I don't like to push my stuff, and this thing's already got soft tubes in it, and plus those tubes are almost unobtainium. If you find a good pair of them, it's probably $600-700 each. So if you're gonna find a good pair or a new pair of them, you're gonna probably pay $1,200, $1,400, $1,500. A lot of people mod this amplifier because you got a nice compact unit. You know, you got a healthy 24-pound transformer. You know, you got the metering and all that, tune and load. You got the basic full build of an amplifier, and all you'd have to do is change the tubes and the sockets and probably the cooling. Because one thing about these weird tubes, these 8875, do I got one out? Yeah, I got one from the other one out. They're fan cooled. The fan blows across the fins. So cheap way to do it. You don't have to use a blower and a plenum and forced air and all that other stuff. But since these tubes are unobtainium, most people are going to, you know, maybe a single 800 or a couple 4CX 400s in it, or maybe even a couple 4CX 250Bs. But a 250B, you know, you're going to get 500 max out of each tube. So if you put a couple 250Bs in there, again, you're going to expect to get what it's doing now, about 1,000 watts out of it. So that'd be a lot of work, you know, with not that much gain. That at least 250Bs would be a lot cheaper to get than these unobtainium 8875. So anyway, that's going to be it for this Dentron MLA-2500B. I like it. I wish the tubes were cheaper. But other than that, decent amp. You know, not the greatest engineering job in the world, especially with the ham bands and all that stuff and the long path it takes. But, you know, you monoband it, you can make it a pretty decent amp. And, you know, when you monoband it, it gets rid of all those harmonics and parasitics and all that from having all that crap in it too close together and all that. So anyway, my thoughts on this guy. Audio. Run it like that, I probably can get another 10 years out these tubes. You push it hard, these tubes aren't going to last no time if you push it too much more than that. Anyway, that's it for this one. All right, bye.